Here we have a pre-calculus problem. Okay, let's go to the question. Is the function f continuous at x equals to 3? Okay, we have a piecewise function and we have to check whether the function is continuous at x is equal to 3. Okay, whenever I have a function and I want to check whether the function is continuous at a particular value of x, so I have to follow 3 steps. What are the 3 steps? So the first step is I have to find the value of the function at the given value of x. That is, I have to find f of 3. So this f of 3 must be a real value. So this is the first condition. And the second condition, I have to find the ordinary limit of the given function at the given value of x. Ordinary limit or two-sided limit. That is, limit x tends to 3 f of x. So the result of this limit has to be a real value. So this is the second condition. And the third condition, so the results, what I have received in the first step and second step must be equal. That is, limit x tends to 3. F of x must be equal to f of 3. So when all these three conditions are satisfied, then we can say that the given function f of x is continuous at x equals to 3. Okay, so for that first we have to get to the first step, that is we have to find the value of f of 3. F of 3 means into the given function f of x I have to plug in x equals to 3. Okay, let me do it. So f of 3 equals to what? So among the given three pieces we get f of x equals to 1 when x equals to 3. So when I plug in x equals to 3 over here, so then the value of the function equals to 1. So f of 3 equals to 1. Okay, now I have to find the two-sided limit or ordinary limit at 3. So how do we have to do? So actually it's a piecewise function. So since it's a piecewise function, here we have the first piece for x less than 3 and second piece we have for x greater than 3. So we have to find the left side limit and right side limit. If both of them are equal, that is the result for the two-sided limit. Okay, first we have to find the left side limit. That is limit x tends to 3. I just mentioned the negative sign on the right side top corner of 3. So the negative sign indicates it's a left side limit of 3. So left side limit means that is x approaches 3 from its left side. For example, let's draw a real number line over here, 3. X approaches 3 from its left side. So all the values over here will be less than 3. So in the given piecewise function, we have to consider the piece that we have for f of x where x is less than 3. So this is the piece, that is absolute value of 4 negative x we have for f of x when x is less than 3. So that's what I have to plug in over here. Let me do it. Limit x tends to 3 minus. So when x approaches 3, that is when the values of x are less than 3. So the piece we have for f of x is absolute value of 4 negative x. So that's all. The negative sign will not do anything more with this calculation part. So we use this negative sign only to select the piece that we have for f of x. Otherwise, this negative sign has to do nothing with the calculation, what I'm going to do further. Okay, now let me do the further calculation. Okay, now what I need to do is I have to plug in x equals to 3 into the stuff over here. Then I'm getting absolute value of 4 negative 3. So which is equal to absolute value of 1. Absolute value of 1 is just 1. Okay, now I got the left side limit of 3. Now what I need to do is I have to right side limit for 3. So that is limit x tends to 3 positive f of x. That is, this time x approaches 3 from its right side. That means all the values over here are greater than 3. So in the given piecewise function, we have to consider the piece we have for f of x where x is greater than 3. That is x squared negative 8. So now limit x tends to 3 plus. So now for f of x, what I can plug in is x squared negative 8. So x squared negative 8. Now I can plug in this 3 for x, and I'm getting 3 squared negative 8, which is equal to 9 negative 8. Finally, it equals to 1. Okay, so what is the left side limit of 3 and what is the right side limit of 3? So for both the left side limit of 3 and right side limit of 3, we get the same result, that is 1. Then now we can write the ordinary limit or a double-sided limit for, that is limit x tends to 3, f of x equals to 1. So the left side limit of 3 and right side limit of 3 must be equal and they must be real value. So that we can write the ordinary limit, that is limit x tends to 3, f of x equals to 1. Okay, now I have completed the second step. This is the second step. So in the first step, I got f of 3 equals to 1. It's a real value. And in the second step, I got the ordinary limit for x equals to 3. So that's also 1. Okay, now verify the third step. That is the result of what we got in the first step, result we got in the second step must be equal. That is limit x tends to 3, f of x must be equals to f of 3. So this is the stuff we have in the second step. This is the stuff we have in the first step. Both of them are equal because both of them are same. That is 1, finite value and real value. So the given function is continuous. Since all the three conditions satisfied by the function at x equals to 3, we can say the given function continuous at x equals to 3. So when I go over the given four options, the correct answer choice for this one is option E, because limit extends to S means the function is continuous at x equals to 3, because limit extends to 3 f of x, the result of the second step, and f of 3, the result of the first step. Both of them are equal.